Hello, whoever is watching. My name is Ashley Cowan-Smith, and today I'm going to talk to you about the body plans of the origin of tetrapods, and we're going to talk a little bit more about some more current modern-day extant rhinocephalia as well. To jump right in, we'll start with our prolififorms. These guys existed around the Devonian period, and something really neat about them is they have these paired fins, and they're definitely lobes. So if you remember coelacanth, really similar fin structure here. This is going to help them move through the water a little bit easier as well. They've got a fused neck too, so they cannot move their head side to side or up and down without moving their whole body. So this is definitely not something that's terrestrial ready. It's definitely more aquatic, especially when you look at these dentine scales too. They're made of enamel and dentine, really similar to what we have in our current fish, but not quite. Yeah, we're water dwelling right now. Next, we'll take a look at Tiktaalik. This fella lived in the late Devonian period and was known as the fishapod for a couple of reasons. Biggest one being that it was kind of our bridge between our ancestral and derived form of tetrapods right now. So it has these bony scales, still that we had seen with fish. It had these ray fins, so different from the lobe fins, but still fins nonetheless. Its vertebrae was really poorly ossified too. It's really similar to a fish too. And it even still has its gills too, because it has the our operculum is still here. But here's the thing, is that it has lost the bony operculum, but it still has gills, but it still has kind of the spot for them. It has ribs too. We're starting to see ribs come in. They're large and overlapping. And then the coolest part about these guys, what makes them so important too, is we see a basal stylopod, a distal zeugopod, and a radial dermal bone happen. So what that is here, as you can see in this picture, it says elementary wrist. So we have the precursors basically to our radius and ulna, our tib, fib, and our wrist, our phalanges and everything right here. So it's not totally there. Obviously, like look him try to lift himself up. He can't totally go on land yet. He can, but not well. But this is totally helping, especially with those ribs too. Oh, and one more thing I want to take a peek at too before we move on is the eyeballs here on the top of the skull. Notice where those are located. We'll see them with our next creature here. Bam, our stem tetrapods. So we have Acanthostega on the top and Ichthyostega down here on the bottom. With Acanthostega, we still have our operculum with gills. It would have been right about here. We have a dermal fin ray. This is really similar to like a fish fin ray down over here. And we have our better neck movement, similar as how we had with Tiktaalik, but look where those eyes are. Really close to Tiktaalik with the eyeballs. What's really cool about these two is, specifically with the Acanthostega, they were octidactyls too. So they had 8 little precursors to fingers, little phalanges on our little toesies here, but they were definitely still more fin-like. Also, can you imagine having 8 fingers? A little bit crazy. With Ichthyostega over here, these ones, they were heptadactyls. So we move from 8 to 7. And we'll notice that is going to start to kind of play a role here. We'll also see a much stronger vertebrae here, and this is definitely going to help play a role with that transition onto land. So like with Acanthostega, this tail, very fishy. These flipper fingers, very fishy. Up here though, eyes on the side of the head, a little bit more terrestrial, stronger vertebrae. Look at those overlapping ribs. This is definitely for land walking. We've also noticed over here with this one, I know these are skeletal pictures, sorry, but this one was definitely more scaly with Acanthostega, but with Ichthyostega, we're starting to see reduced scales. This is better for gaseous exchange, but it's starting to look a little bit more skin-like too. From there, we hit our reptiliomorphs. These fellows lived in the late Carboniferous period, and they're our ancestors to our extant reptiles right now. You'll notice, similar to Ichthyostega, we're starting to get a much more elongated body shape. And look at the eye location, too. Look at that on the side of the head. And look at those toes. Guess what? They're pentadactyls. 5 fingies on those toes. So it's definitely more terrestrial based for all of this. We'll still have our rib cage going on. This is more skin-like. We're starting to definitely get more used to land. Our early tetrapods now, we're talking about our batractiomorphs. We've got two different groups here to take a peek at, the temnospondyls and the leptospondylus. The temnospondyls were very diverse. This picture here is kind of a body map of what their body mass would have looked like based off of their skeletal features. For the most part, all of them basically had very predatory jaws. So for the diversification of body plans, they had a whole bunch of different prey to look at onto land. So they had to increase their jaw capacity, basically. We've also got different types of scales and armor happening, and these ones are definitely a little bit more on the semi-aquatic to fully terrestrial side too, just based off of everything that we're seeing from that bone structure. Versus the lemnospondyls, on the other hand, also very diverse, but kind of in where they lived too, because they were aquatic, semi-aquatic, they could have been terrestrial too. But the weird part about these guys, look at that head shape. What is going on there? It's kind of like a boomerang shape. This could be for a couple different reasons, is because we're starting to really diversify with our socialization skills and using our body parts for that. But also, think about where they're living. They could be kind of anywhere right now. So this could be for aerodynamics, for in the water to help reduce drag, because they kind of still have like this very long tail going on too. So on one hand, it could be for water, it could be for socialization, but it could just be for all of the above. Next, we'll take a peek at our amphibians. These guys are next on our list. We'll be looking at frogs, salamanders, and caecilians belonging to this clade. A really defining feature is their permeable skin. So look at our salamander here. This here is our beautiful long-toed northwestern salamander here in Montana. You'll see its skin looks really wet. It's still going to rely on water a little bit. And it's got, a lot of them have an operculum camella complex too. That means their bones that are derived from their hyoid bone transmit sound to the inner ear. So it's kind of like their ear, but it isn't. It's somewhere in between. We'll also have a papilla, aphamborium, and basilaris. The aphamborium, that one is going to be basically cells on the inside of the inner ear that are really sensitive to low frequency. And then the basilaris is going to be really, really sensitive for high frequency. So this is going to help them hear without having like totally ears yet. They also have a levitator bulbi muscle. This guy, take a look at our long-toed salamander here. Look at those eyeballs bulging up. That is from our levitator bulbi muscle. It's basically a sheet of muscle on the bottom of the orbit that pushes those eyes out. So they look all cute. So because of that, salamanders in particular, they're really common to have something called petamorphosis. And that's really just keeping young features into adulthood. So they'll have these cute big eyes and big heads. They won't fully look like they're adults. They'll really look like they're youth form. Salamanders in particular, they also don't have ribs. So imagine not having your ribs. They can squish down really well. And that'll help them hide underneath rocks, twigs, logs. They are not predatory a whole lot. They hide a lot. And not having ribs will really help that. You wouldn't really need that a whole lot in the water. That's definitely helpful for more on land, because when you're going to need to hide between a couple of rocks in the ocean, you know. They've also, because they don't have ribs, they rely on buccal pumping. So really similar to some older fish that we were looking at, is they kind of have to suck in their jaws, and that's how they'll ventilate rather than using their lungs automatically. One more thing before we head on out is they definitely had an ancestral gait too. Is look at this little fella. Look at how do you think he would walk? He's definitely got to wiggle almost his whole body back and forth, and really resembles some early tetrapods with that. Next up, we'll take a look at our amniotes. We are going to discover eggs. Yay, a little bit more solid eggs anyway. They're definitely more lizard-like. We're experiencing a longer neck starting to happen, and they have costal ventilation. So in these little ribs, they can use their lungs to actually breathe in and out. We are also going to start seeing some temporal fenestration here, like in this picture. We have the anapsid skull. This one's not going to have a bony arch, just a loop on the side of the skull. It looks pretty solid. Versus over here with our synapsid skull, this is going to be a single arch or some temporal bars between and below, but the giveaway is that we have our part for our eyeball and then this hole right here basically. And these guys are going to be really common in mammals and not a whole lot else. Basically everyone else who had a synapsid skull is now extinct. And then for diapsid skulls, this is going to be part of our dinosaurs, our turtles, our crocodiles, our birds, and this is where we're going to start to see it here is with these fellas. This feature is definitely more terrestrial based, mostly because you'll start to see these in our mammals that are starting to come up. Lastly, we're going to talk about our testadunes. These are our turtles. Yay! Late Triassic period for these fellas, and then we are looking for a really big body plan that has a dermal bone, carapace, and plastron. The carapace is this part on top, and the plastron is on the bottom. And they have beaks too, so we have our defense and our offense. Depending on what species we're looking at, we have some Cryptodira and Pleurodira. The Cryptodiras, they're called hidden necks. So basically they can take this head and just retract into that shell, versus the Pleurodira, there's kind of just like a divot on the side of their shell, and they can kind of hide their head in there that way. It is a little bit more out there, but it's still pretty hard to get to. And that's definitely going to help you with land-based predation. Because, I mean, what use would that be in the water, you know? We are definitely seeing this for land use. Another really cool thing about them is their limb girdle location. Where their rib cage is right up here, right underneath the shell, and their limb girdle is in their rib cage. So that is another little neat thing about them. So, thank you for coming to my not a TED Talk. I know I talked really fast. I probably coughed a couple times, but thank you for sticking around nonetheless.